Hey everyone, welcome. It is Friday. You've made it to the end of the week. We're up bright and early here in Seattle. It is 7 a.m., which is crazy. I don't even know if the sun's up, which is even crazier. But I hope it's a good day for you already. I hope it's a good start to the day. We're gonna have some fun today and do edge detection. So if you've been following along in the series, right now we have a robot that has a little microcomputer on it, which is a Raspberry Pi in this case. The robot is a Roomba. So you know the nice little vacuuming robots. There's a serial connection from the Raspberry Pi to the Roomba. We're able to send commands to it through voice. So we can say, Alexa, tell the robot to go to the kitchen, or, well, we can't do that part yet. That's coming. That's part of today's episode, is to get to that point. But right now we can tell Alexa, tell the robot to move straight or turn left or spin around. As of a couple of weeks ago, we were able to get the robot to take a picture for us. So now it can take a picture. Alexa, tell the robot to take a picture. It'll take a picture, it'll identify people, it will recognize some people, so I've trained it to recognize my face and my son's face, and it will outline objects, and then the cool part is it will take that picture and put it on our Echo, so we can see it on any device that has a display using APL. So I can say take a picture and it will show me the picture, show me all the outlines in the picture, all the people, etc. So that's where we are today, and this is all building up. Hey, good morning, Paul. You've been looking for some edges. We are, sometimes we're a little rough around the edges. We're going to smooth them out today. But the edges are important. That's all going to tie together for us to help us do navigation. So I think what we'll do is use edges to detect points that we don't want to get near. So right now the Roomba does a really good job of using some sensors and using some bumpers. When it gets close to an object, it can tell. When it hits an object and that bumper depresses, it can tell, and it will rotate and switch and move around. So we're going to help it by giving it some edge detection. So let me show you a video I have. This is on the robot. Let me drag it over here where you can see it. There we go. This is in my hallway. So what you're seeing here is the robot, the Roomba, moving down the hallway. Just moving real slow down the hallway. We're going to use this as our source video today. So there's no sound. Don't worry, you're not missing anything. In fact, I think I'm going to walk into the frame here in a second accidentally. But it spun around. I'm not sure what it saw. There's me, it saw me and it turned away from me, and now it's heading towards my kitchen. It's gonna hit that wall, spin again. So it's kind of aimlessly, well, not aimlessly, but it's got a purpose, but it's really spinning. We're gonna try to help it a little bit more. So this will be a lead up to getting us some navigation. All right, so that's the video. We're gonna start with that one. And we're going to use something called OpenCV. So if you haven't used OpenCV, this is kind of the classic way this is done, this edge detection is done. It's not a new concept, the things I'm going to show you. Like some of the algorithms and methods were invented in the 80s, or the ideas at least were born in the 80s, but they have been perfected over the last 20 or 30 years. And there are different ways to do this now. I want to show you how to start, because this is a very accessible way to do it, where you can do this in a matter of, we're going to do it in an hour or less. Maybe a new way, if we look at that video again, did I already close it? If we look at that video again, the new way or a different way would be to use a machine learning model. So maybe you're training a model on what a hallway is and what these, what are these called? Floorboards are. So maybe instead of doing edge detection where we actually outline what these things are, we have a model that does it. The problem with this, and I heard a really good podcast last week with Colin Engel, the CEO of iRobot, he says that driving in a house autonomously is more difficult than an autonomous car. It's because of this. Like in this house, we have lots of different things happening. We might not have these white baseboards or white cabinets. Obviously, driving a self-driving car is more dangerous and has a lot more risk involved, but this is tricky. So I'll show you the way we're going to do it with edges, but if you want to do it a different way where you train a model to recognize edges, you could do that too. All right, so let's get started. We're going to use OpenCV, as I mentioned. So let's do, we'll just call this main.python. And I've got, OpenCV comes in as CV2. Can you see that font? Okay, let me blow that up. Be sure to put your questions here if you have them as we go along. I think we're going to need, let's see, we'll need sys most likely. So let's just start this off. Process video, we'll make a new method called process video. And what I think we'll do is, we'll make this variable, so we'll call it, we'll just call it video. And let's get a name here. So video is going to be sys.argv1. So this is when I type in Python main.py space hallway.move, it's going to get hallway.move as the video. So process video, we're going to put this here. All right. The tabs look off, don't they? There we go. So we have the video. Let's do CV2. I believe it's load movie. Let's see. We'll find out. All right, OpenCV. When you're doing anything with OpenCV, load video files is what we want. Kind of append, especially in Python, append a Python, because there's a lot of C code that you might get to, C++. But if you like Python code, then type in a Python there. All right, so let's see. Reading a video. This is what we want. Video capture. This is the command I want. And we're going to call it video. So let's say while, well, let's just look at how they do this. Cap is this, cap is CV2. All right. Let's just make sure it's working so far. All right, so Python main.py, hallway, can you see that? I'll blow this up a little bit. Font is, we'll go 24. All right, that's better, right? There we go. All right, so no errors. But just make sure we're here though. What we'll need to do is like while cap probably dot, is there a read? For some reason I think it's not loading CV2. Displaying a video, okay, this is what we want. CV2, if cap is opened, while cap is opened, here's what we want. We're going to copy and paste a little bit today just so we can get through this in an hour, but I think we'll get the idea. So while the capture is open, so we're opening the video, while it's open, we're going to get two things. Let me show you what this return and this frame, these are. Let's just do cap.read, print cap.read. We'll exit right after this, just to show you what that looks like. My indentation. What did this say? 15 expected an indent block. Usually, oh yeah, that's because of this. Let's go ahead and comment that out too. Okay, cool. So we're getting, these are NumPy arrays. So these are like arrays of pixel values and things like that. So we're getting a true as the first value, then the array, this is of one frame. So imagine that hallway frame, we're taking one frame. We know that it's we received the frame, okay, and now we have all the pixel data. So pixel data comes in red, green, and blue, or sometimes I think with OpenCV it's actually red, blue, green, RBG. It's a little bit different. Or BGR, it's BGR, which is a little bit confusing. So the BGR values, so the blue pixel is 78, green is 96, and R is 118. Those are the pixel values of that entire first frame. So we don't need this ret value, and that's why we can do, we can just ignore it. So let's do this. We do want the frame, and if oh, I see what it's saying. So maybe we do. This code says if we are getting a true there, then let's move on. So that's okay. I don't mind that. Now we want to show it. So let's do cv2 .mshow. Maybe it's mshow like that. Give it a window name. We'll call this original, and we're going to say we want to give it the frame value or frame data. And then we want to wait for a key. Yes, that's better. Hey, Flyboy, welcome. All right, so we're going to wait for a key. So if we didn't wait for this key, I think the we can say if cv2.wait key. So this is the number of milliseconds. We're going to wait 1 millisecond and show the next one, the next one, the next one equals the ordinal of q. So this means if we hit q, then we want to stop. So we want to stop this. So we're going to say break, and then I think that'll be good. Let's see if this works. I'm going to move this over so we don't have to keep jumping back and forth right now. There we go. You see that okay still? And I'll close this. We don't need this. Yeah, it's better. Good morning, the Trinity. How are you? All right, let's try this. CV2 has no, I think it's just mshow. Let's try mshow. If not, we'll look at the documentation. Oh, we got it. So it's loaded on this monitor. Let me put it here. Definitely too big, but you can see that. How can I resize this? Let's do that maybe. Yeah, it's pretty big. So we're gonna resize this. Remember, I can hit Q to get out of it. And sometimes it does it fast, sometimes it doesn't, just depending on the buffer. We're gonna stop that though. So good. So what we need to do, let's, ideally you would take it and you would resize your video before you start processing it. I'm not gonna do that, I'm just gonna resize on the fly. That's not a good coding practice. Next time, if you're doing this in real life, you'd wanna take your data, maybe it's a higher res video, shrink it down, then process it. We'll just kind of shrink it on the fly. So we'll do resized equals CV2, is it resize image? Let's find out. Sir, install OpenCV Raspberry Pi can be a challenge. Intel put good efforts to prepare installers for its OpenVino toolkit for different platforms. Oh, that's awesome. It's a huge challenge. The only way I've been able to do it successfully in a short amount of time with Raspberry Pi is to use a package like Anaconda or Miniconda. There's one called Pi or Berryconda. And then with that, you can say conda install OpenCV, and it is so much easier than what you and I are used to, Serge. But I love it. I've never heard of OpenVino. I'm going to take a note and look at that one later because that's always a pain. OpenVino Toolkit. Thanks for sharing that. If you get a chance and you want to paste that link, we'll look at it. All right, so resize image. Let's just, oh, there it is. That's resize. Okay. So CV2, whoops, resized equal CV2 resize, and we're going to give it the original image, which was frame, and we're going to give it a, we'll just do 400 by 300. Let's see what that looks like. We'll show the resized now instead of the frame, and let's check this out. I wish I could get it. Actually, I know how I can get it on this monitor. Let's see if it pops up over here first. It does, but it's much smaller, which is perfect. Okay, so I'm on a 2-monitor setup. The my right hand side is the primary. My left hand side is the secondary. So what you can do is move these. Whoops, Q to get out. What you can do is move the window. So I think what we'll do is look up that command and we'll move it over to the left side. Okay, so move window, move window, move window, mshow. Oh, right there. CV2, move window, window name, and then the position. All right, we can do that. So we're going to say CV2, move window. The window name is original. It's actually resized. Position is going to be, so I'm left, so I'm going to go negative. Let's just start off at negative 1500, and we'll bring it down 20 pixels from the top. We need to move this right here, and we'll call this resized. So we're labeling the window as resized. We're putting the resized frame there. We're moving it over. Let's see if that works. There it is. Okay. So we have some more pixels to play around. If this is 400, then we have at least another 400 to move. So we'll go negative 1900. And we'll close this. All right, so that's the first step. While it's rolling, I'll show you what we're going to do on the next step. So traditionally, the next step is to remove artifacts. So you can see, maybe not now that I've resized, but there are some little artifacts, and even some of them are not even digital. Like you can see the paint at the bottom of my baseboard sometimes bleeds up a little bit into the brown. That might be an artifact. Or some of these rough spots at the bottom of my floorboards that need to be reworked a little bit. Those might be artifacts. And so a classic way to get rid of artifacts is to blur. So we can do a Gaussian blur, and we'll do that now and show you. But before we can do edge detection, we'll need to clean up just a little bit. So let's do blur equals CV2. I wish this would pull up. That's all right. Gaussian blur. Actually, before we blur, there's that. That's what I needed. I think before I'll blur, so here's another thing you can do. Another thing to make it more efficient, the processing more efficient. So if we look at these, if you think about these are all pixels, right? So these are millions of pixels. each pixel has a three-dimensional value for its red, green, and blues. We want to convert. Our system really doesn't need that to detect edges. So we're just going to convert it to one value of pixels, because all of this is a lot of machine learning is just matrix multiplication. So you've got these three channels, these three dimensions that you're going to multiply. It gets a lot more complex than if you just had one. So the way to get one is to convert that to grayscale. So before I blur, let's do a grayscale. So that's called convert color. And these, hopefully it'll pop up for us, because there we go. So the source is going to be resized. So resize, and then these codes for color. Code. I think it's BGR to grayscale. CV2 dot. Let's see if it pops up. BGR. Remember, it's a little bit different. BGR to gray. All right. Are there any more parameters it needs? And then okay. So we'll call this grayscale. We'll just call it gray, and then we'll make a new, we'll show it next to that window. So cv2.mshow the gray. Call it gray, that's fine. And we're going to do gray here, and then we're going to move it over cv2.move window. Move window gray over to, let's say, negative 1480, and we'll keep it right next to it at 0, or 20. That should work. Let's try it. Any more questions? I'm not able to send links. Okay, we'll do that. Thanks, Serge. Good. So we have, on the left, you can see it. We have the color image, and on the right, we have the grayscale image. So now we've got it in one channel. It should be a lot easier for our system to work with. So the next step is we'll get rid of artifacts. So any kind of artifacts we can get rid of with blurring. Let's do that. So blur is Gaussian blur. And the parameters it needs are probably the source image, which is the grayscale now. The next one it needs is the kernel size. So kernel size is, a kernel is typically a 3x3 grid, or a 5x5, sometimes 7x7. It really depends on the image size. Since we have a 400x300 image, we'll go with a 3x3. Basically, it takes a square, it moves it all across the image, it does some averaging, and then that's how it blurs. It takes the average and then replaces those pixels with the average. So 3x3, sigma x. Sigma x. Let's look this up. I don't remember sigma x. Oh, standard deviation in the x direction. I don't know what a good value for that would be. OpenCV Python Gaussian blur. All right, so here's the kernel. This one's using a 5x5. Image blurring, image smoothing. There are a couple different methods here. So one is just blur, cv2.blur, Gaussian. Okay, so 0. So 0 for standard deviation. Let's just go with that one. All right, now that we have that, just copy this, and we're going to show the blurred image next to the grayscale. So this one will say blur. And we'll move this one over to 1060. All right, no questions yet. Let's try this out. All right, cool. So I don't know if you can tell or not. I can tell on this, but I'm not sure if you can tell on the stream, but it is blurred. And just to show you, let's increase that kernel size from 3 to something obnoxious. How about 15? I'm not sure why the Q doesn't work sometimes, this wait key. Yeah, you can definitely tell on that. So that's a 15 kernel size. It's not terrible. I thought it would be a lot worse. And so I'm thinking now that I'm going to move from 3 to 7. We had it at 3. Let's just kind of cut the middle. Oh, so since you're doing a grid and you need a center pixel, it needs to be an odd number, by the way. All right, so we have that. I'm going to go with 7. Okay, so we've grayscale, we've blurred. Now the next thing we can do is we're going to detect the edges. So let's do edges equals cv2 dot. This is a pretty straightforward canny edge detector. Is a classic algorithm. So the input is going to be blurred or just blur. All right, edges. Let's go look at someone's code for that one. Canny edge, Canny Python. Yeah, this will be a good one. So what happens, there's a threshold. So basically it's looking at lines. It's going to see, okay, is the way it sees lines is, if we go back to the image, the way this works in a nutshell, it's really good if you want to read it, but it's in depth, so it will take some time. But you see here, like, let's just look at this part of the baseboard. Can you see my cursor? Yeah. There's a dark, gray here. If we're thinking about things in terms of 0 to 255, 0 being black, then you can almost see that there's 0 or 10 pixels here, and this one gets into the 200s maybe, or the pure white is 255. Maybe there's some pure white here. But anywhere there's a harsh separation of that pixel value, that's where Candy says, okay, I think this is an edge. And you can control like how harsh that value is with these values. So there's a maximum value, there's a minimum value, and if it falls, if an edge starts here but falls and it kind of falls down a little bit but comes back up, then it says, okay, I think that's part of the same line or the same edge, and so I'm going to count that as a line. But take time and read that if it's interesting. This is the part of the technology. I think Candy came out. Here's a 2002 one, but I think the process itself for this, or the theory of it, was all the way back in the 80s. Excuse me. All right, so Canny, so image 100, 200. I think that's just the max threshold and min, but let's make sure. Min val and max val. All right, so let's go back to our code. Where's Canny? Blur, and then we're going to say, is it minimum first? Threshold 1, threshold 2. All right, we'll just say 100, 200 and see what happens. So we get edges at that point. Now what do we do with the edges is the question. So we get the edges. Let's show the edges just like we have before. So we're going to show edges, a window called edges. You can name that window whatever you want. I'm just naming it the same as the image itself. And then this one will be at, we'll take out 420. So what is that? What is it, 1480? See how that looks. Move window, show edges. Did I? Oh, it's behind it. Okay. How did I do that? Oh, I see. Blur is here. There we go. Did anyone catch that? No. I've caught you sleeping. All right, so edges, we're going to go to 9. What is 1060 minus 400? 9. 429. 940? Oh, what am I thinking? 640. It's too early for me to do math. How would you ignore edges on something like a throw rug? Okay, that's a good question, Paul. So right here are the edges. As you can see that 100 and 200 do pretty well. I definitely have the baseboard. I definitely have a wall, some doors, so this is good. So there's another technique you can add called ROI. It's a region of interest. So for a throw rug, okay. So in ROI, we could do this. You basically build a mask, and I'm going to point at this blurred image. So you take a mask and run it. Like, we don't care about anything on the floor. We really do, because we might not want to run over people or toys. Maybe we do. Maybe we're making a toy pickup app. But let's just say we want to avoid throw rugs. We could do it by creating a region of interest. So you would create a mask in the image that says, don't pay attention to anything in this mask, but pay attention to everything else. That's one way you could do it. I think another way to do it would be to use something like onboard video recognition, like processing to train it for a model that has throw rugs in the model. So maybe that'd be a cool way to do it too. So if the Raspberry Pi notices that in the room as it's traveling on the Roomba, then it says, oh, abort mission, go back. I would actually like to do this, because the one problem I have with mine is I have curtains in one of my rooms that hang to the floor, and Roomba, whose name is Bert, in my house from Mary Poppins, the chimney sweep, Bert eats our curtains. So I could make a region of interest where, I don't know, that'd be a tricky one. I'd have to train a model for that maybe, or just lift my curtains off the ground, which I kind of do anyway. Why isn't there an edge found at the bottom of the floor molding and above it? Let's go back and look at that. And then how do you adjust the thresholds of the candy filter? The thresholds are here. Hey, Soundmaster, welcome too, by the way. Ask Alexa for all math. So the thresholds are right here. So I could really say threshold 1, which I believe is the max. Threshold 2. Let me check. Is this still trying to quit? Paul, I'll come back to your question for sure. I want to look at that video. All right, so we're out of that finally. So 100, 200. There's max val. I think max val is first, so it's the max. I really want the API for it, but I don't see. For these, we need 2 threshold values, min val and max val. So min's first, min and then max. So you can adjust those values. Let's adjust them before we run it again, then we'll look at this baseboard issue, or the molding issue. So we were at 100, 200. Let's go to 20. Let's keep it at 22, and let's not change both of them. And let's try this again. Okay, so I seem to be getting more edges. Paul's question was, why isn't there an edge found at the bottom of the floor molding and above it? Oh, okay, I see. Yeah, you see every once in a while, I just saw one pop up. There's a plug, that's cool. But you're right, there should be one. Oh, no, that wasn't, yeah, that's the molding, but not necessarily the baseboard. So what's happening is, that's probably a threshold thing. So the threshold, let's play with that real quick and see. Threshold 2. Let's go crazy. 310. Quit. Exit. Quit. I'm really gonna get, really gonna make this mad. There we go. And it will have its revenge on me by not cooperating. All right, so the threshold really hurt us that time. So adjusting that either to 10 or 300 hurt. I'm gonna go back to 200 and 50. Let's see what happens there. Or sorry, 20 and 50. I'm just trying to control C. There we go. Let's see what happens. There we go, Paul. Look at that. So it is a thresholding thing. We pick up a lot more lines. It's interesting that. So what's happening? It's picking up the reflection of the door jambs right here. So this would be a very good use case for defining a region of interest. I would show you that on the stream. I've done this before. What you have to do is use a different program called PyPlot, and when you hover over your mouse over, it will give you the XY coordinate of your mouse. So I would say that this was, you know, like, if this is 400 by 300, then this might be 0 and 180 or 200. So you would basically draw a polygon, and I would draw a trapezoid, floor-shaped trapezoid, and that would get rid of those reflections that I'm getting. That would just cut those out. In the interest of time, I'm not going to do that, but that's the method, so I'm going to say to define region of interest, look at, let's see, OpenCV Python region of interest. It's just a draw. I think it's just a CV2 draw. Set image ROI. That's cool too. If it's only a rectangle, I really wish it could be a. It needs to be a polygon in our case. We need to have this angle that we draw. Give this one shot here, but same thing in 3D cameras tracking. Got to mask out the reflections. You know what? There's one thing we can do that'd be more simple than ROI right now for this episode. So let me think about what it is. OpenCV edge detection masking. There are like lows and highs. So what we can do is say we can tell our edge detector to ignore any value of white over a certain level. Basically anything that's white in a certain level we want. So let's see if this has it. Now we're in C. C++. It's not my strength. I thought I typed Python, but I did not. It's okay. Yeah, let's see here. Those are fun edges. So he's doing the same thing. Name window, show it. Okay. Where's threshold? Canny. Oh, that's that. Okay. We've already done canny edge detection. Did I type in mask? I did type in mask. Let's make sure it's getting mask. Plus mask. Andrew Ng explained very well. Andrew, oh, good. Clear and other edge detection. C4W1LO2. I'm gonna copy that one down. Thanks, Serge. Andrew Ng is great. If you haven't watched his videos on YouTube, definitely take the time. So that is good. That's awesome. Okay. So we need it between, if it's, oh, I think it's I know what it's called in range. Yeah, this is what we want. So we're gonna just try to set a range real quick. Here it is. Mask is that lower red, upper red. Okay, these are arrays. All right, let's do this. So one thing we'll need is NumPy. I haven't imported that yet. NumPy as MP. You'll need that to work with these matrices. Before we do edges, let's do this. So lower red, we don't really care. We're not looking for red. This is how things like there's a lot of robot kits that can follow lines and colors. So these are how. This is one of the methods I use to make those work. Since I know my baseboards are white, you wouldn't want to do this in your house, but since it's specific to my house, I'm going to do it. I'm going to look for white. So lower white would be something like, let's just say 100, 100, 100. Anything that's a 3, if the numbers are the same, 3, then it'll be a shade. Well, we're working with grayscale anyway. So 100, you know, is like 100 levels above 0, which is black. And then the high white, maybe I do want bright white. 255, 255, 255. Our goal here is to try to ignore those reflections on the wooden floor. Mask is this. We're going to mask the blurred image, and we're going to say lower white and upper white. Whoops. And then edges is going to get edges based off the mask. We'll change that. We'll show the edges. Let's show the mask too. I'm going to move this one under the first one. So we'll say mask is here. And we'll say this is going to be negative 1900 and 320. No, 340. All right. Thanks for that tip, sir. That's great. I actually want to move the edges over. So we're going to call this edges. Whoa. Edges copy paste and mask copy paste. Or just type it. Let's move it underneath this 340. Let's see. Mask is. Yeah, let's move this here. Negative 640. Okay, so what I want to have is the mask and the edges right below it. All right, I think that should work. Let's check this out. Come on, little buddy. All right. Upper white is not defined. I thought we did lower white. Okay. Sorry, that should be high white. Whoa. WHIGT. Was that the name of the, was that a White Walker in Game of Thrones? Weren't they spelled W? That's a cool word. All right, let's try this again. The size of an argument is not mentioned. Lower boundary is neither array of the same size as source. What does that mean? So the shape, it's got to be a shape. NP array. P array. What if I just do? Let me see. So if you're working with a 3D shape and then try to apply, I think I'm trying to apply a mask of a 3D shape here to a 1D image. So what if I just say 100 and 255 and see if that works. All right, cool. So we still have some, I guess this is reflection here. You can see that, right? We still have some reflection. Boy, it got a lot of the wall too. So my thresholds are a little off. I'm gonna give this mask, how much time do we have? 36 after? Yeah, we've still got time to finish this up. We can still get this mask to work. All right, we just need to play with this value. So let me think about this. Lower white was 100, high white was too high. Let's go with we're at 255, let's go to 155. Let's just go to 50. Make it kind of more. There we go. I'm just arbitrarily trying things. Whoa, too much. Way too much. So we need to... we definitely need to change that. So 50. Well, what was it before? 101, 255 was closer. What if it's like 235 and 200? How's this gonna look? In addition to the mask, Soundmaster says, in addition to the mask, let's get this running right first. Paul says, because of the grayscale, yeah. Let me see. Val X is less than 128. Val X is 1. I don't get it yet, Soundmaster. I want to come back to that. Let me try Paul's and we'll let this run again. Paul's value says 175, 255. So Soundmaster, are you saying to add another line of logic to it, maybe to say, let's see what this looks like. So mask is up here. I actually want to move the edges around. Move Windows 640. Okay, let's just do this. I want to flip-flop these guys anyway. For some reason, I think that makes sense to me. Doesn't really matter. We're definitely getting a good line there, but we don't have the baseboard. I wonder what this is. Is that part of the door? That's the shadow. That's the edge of the door. Soundmaster says, just a posterization filter in Photoshop where it clusters the brightness into bands. So if... see, perfect. Yeah, sad robot. Val is less than 128. Oh, I see what you're saying. Yeah, you're kind of like normalizing. I don't know how to do that on a pixel by pixel basis without really running through this whole pixel array and doing that. All right. Let's pause. Let's put a pin in masking. I love, let's give it one more shot. So 175, 175 wasn't there. Someone give me a couple numbers. Who can get closer? 175. What happens if I just do something crazy like 100 and 120? That can't be good. This can't work. It's better, but it's really not. we can see more things, but I think it makes it more noisy too. Okay. Googled it. K-means clustering in OpenCV. Ah, nice. You know what? I've used K-means clustering before, but definitely not in OpenCV. So that's something. Let me take a note on that one too, because I'd like to learn that. That'd be fun. K-means. We can do this without the mask. The mask is fun, but just like I mentioned, it's going to be tricky if we're just looking for white right now, and yours. Well, if we're looking for my specific scenario, even in grayscale, yours might be different. So let's just ignore that for now. So we're going to put a pin in mask, but I do like the idea of the clustering for it. All right, so we have edges. Let's move edges back to, okay, edges in the good spot. Now that we have edges, let's draw lines. So let's go to, where is my Chrome? All right, so canny edge detection. The draw lines part, I need help with because it gets a little tricky. So OpenCV, Python, draw lines, edge detection. Oh, huff lines. Okay, so here's a huff transformation. This is, there are parameters here that we could play with all day and not get right, but we're going to copy and paste and get them right. So there's a couple of different kinds. We're going to use probabilistic This is going to take the edges that it notices and then say, okay, if I have a pixel here and a pixel here, it does some math to generate the, so you know the equation for a line, y equals mx plus b. It uses that, or it uses the parametric version of that. So there's a lot of pi and a lot of radians. Just honestly things I'm not great at, especially on a live stream. So we're going to copy and paste some of this. So in this example, this person is doing something similar. Instead of using a video, they're using an image. They're converting to grayscale. They're getting the images, or sorry, the edges. They're not using a mask. So min line length and max line gap. What that is you can tell in these edges. So Hufflines is going to look at these and say, okay, if the line is less than x, then I'm not going to count it. If what I see as a line is less than x, I'm not going to count that as a real line. So again, this will depend on your image and the image size. So we'll just kind of adjust it for this 400 by 300 that we have. So why is it still showing the mask? Did I not save that? All right, so let's copy some of this. And we'll go through here and edit this and make it our own. All right, so max line length is going to be, this is again something that's just arbitrary for us. We'll keep it 110, I'm fine with that. The gap is the gap that the edge detector saw. So if you remember, there were some lines that were clearly a line on a baseboard, maybe it had a gap here. We're gonna say, if the gap is greater than 10 pixels, ignore it, it's not a real line. So maybe, I don't know, let's go 30, let's be a little more forgiving. Lines is gonna be the Hufflines, P for probabilistic. There's also a Hufflines regular, but we'll go with that one. We have edges already. These values here are, I do wanna know what they are. Let me blow this up just for a second. See if we can get this to pop up. All right, so row, theta, threshold, lines, image. So the row is this. Theta is this. Lines, min line length. Lines, what is lines? Why is that 100? I'm not sure why he has 100 there. But that's okay, let's do this. We're gonna say min line length equals min line length. Make sure we're getting that. And min line, max line gap is max line gap. I do wanna know what this 100 is. I wonder if pi over 180, so we're just getting the radians. All right, we're gonna try without it. So we're gonna get a group of lines for x. Let's just see what this looks like. And then we'll exit out of it. We'll see if we're getting the right data first. To define region of interest, look at, oh, I was typing that. All right. Positional argument follows. All right, I'm gonna get rid of this 100. I'm not sure if I need it. I mean, I might, but according to this, Hufflines P needs image, which we have, called edges, row, theta, threshold, row, theta, so it's threshold. Threshold equals that. Okay. Mask is not defined. Right. We gotta get rid of mask. Edges, so edges is now going to work off of blur again. Okay. Cool, so these are the lines it sees in the first frame. So these are the XY coordinates of the lines it sees in the first frame. So you can see in the very first frame of the video, 1, 2, 3, 4, 5, 6, 7, 8. 8 lines. All right, good. So print lines, line 0. So we're getting, all right. Print, let's just see what this looks like. X1, Y1, X2, Y2. I don't need this, but I just want to print the first coordinates out and make sure everything looks good. All right, so there are lines. But that's okay for that in line 0. Ooh. That's only drawing one line. Let's just try it first. So I don't care about printing that right now. CV2 line, let's get this. This doesn't look right. All right, so we're gonna draw on We're gonna draw on, so we wanna draw these lines on an image. Let's draw on the original, which we called resized. We're gonna draw X1, Y1. We're gonna draw this color, so it's BGR, so it's gonna be green. Let's make it red. 2 is the line thickness. So for each of the lines, it should draw a line for us on the original image. Or not. Let's see. CV line resized. Should be all right. Let's see where they're showing it. So they're drawing a line. They're writing it to a file. I don't care about that. Let's think. Why didn't it show on that lines equals this? Let's just say found lines. And X1, Y1, X2, Y2, that looks good. Try it again. I don't see any lines. But it's finding them there, so it's just not drawing them. Okay. Let's see. Instead of found lines, I want to, for X1, Y1, I feel like so it looked like it found, let me do this exit. It found 8 lines the first time. So print lines, this should be for the first frame. Here, maybe this is why. Definitely found 8 lines, but it only prints one of those. Oh, here we go. How about this? We know we have multiple lines. We need to do this first. For line in lines. Now we can do this. Yeah, this makes more sense. For X, maybe the other guy was using a image. We're using video, so I think we need to be looping over things. Although he should have found more lines. That's okay. And we change this to line. Then we found a line. We're going to draw the line right there. CV2 line. Oh, we're not. Let's make sure. Let's just re-show this line or window. So mshow. That shouldn't be necessary. Let's see if this fixes this first. Definitely found lines, but it's not drawing them that I can see. So let's just make a new thing called, let's see, let's make a new, so we're going to call it lines equals CV2 dot, this really doesn't make sense. I don't know why it's not showing. Let's try to draw it on the blurred image. So we're finding it in the edges. We're going to draw on blur. I don't really care about this debug line anymore. But I do kind of care about this. Let me say this. Print X1, Y1, X2, Y2. All right. I'm definitely getting coordinates for lines. Is it possible that I have something wrong here? It's very possible. All right, so image, point 1, point 2, color, thickness, line type, and shift. Well, let's go back to 255. They had 255. We're going to go 255. I don't think it matters. And we're drawing it to blur. So the blurred image, which is this one, should have lines on it. I don't see any lines at all. That's all right. We're going to solve this. We're going to call this OpenCV, Python, draw lines. And we'll say huff. All right. Tutorials 1, this probably will be good. It's definitely doing an mwrite. want to see it with a video instead of a still image. There's definitely something simple I'm missing here. How's everyone else doing? What's anyone have good weekend fun plans? I like the cooler weather. I hope you guys are getting outside some too. All right, so once we have the mask, we find the edges. We use Hoff transform. We've done that. So there's our lines. Looks like we're doing all that right. We finally show it on screen. So maybe, so they're writing to a new thing called frame. So let's write to a new one as well. So, oh, I wonder if I just should do, hold on. CV2 line frame. Where do they make frame? Oh, here's some masking right here. So there are their values. They're using 3-dimensional values. So frame is going to be that. So basically frame is blur in this case. Fishing in State Fair, Texas. Nice. I didn't know you were in Texas, Flyboy. Howdy, folks. Is that what Big Tex says? And then, I know you haven't been yet this year probably, but how is or like what are you looking forward to eating? Because there's always crazy things there. Oh, the Seahawks game. That was awesome. I've never been to CenturyLink, so it's my first experience there, and it was an amazing game. I got tickets last minute, but they're actually really good. The game, if you didn't watch it, spoiler alert, the Seahawks won by 1 point because the Rams missed a field goal as time expired. So it was really crazy. It's why my voice is hoarse. That's the loudest place I've ever been in my life. Loudest outdoor place. All right. Lines, M-show. I think I need to M-show again. I think that's part of the problem. So let's try this. Let's M-show the blur. I'll call it... yeah, let's do this. CV2.mshow blur, because we're writing it to the blur, and we want to write that CV2.move. I don't think I have to move the window. It's already there. Yeah, there's lines. All right, cool. So they're black. I don't know why. Oh, because we're not in a color image. That's why. Oh, so let's write them to... Okay, so you see the lines? That's good. That's where we want to be. So let's get rid of this debug. Let's write this to original. We're going to re-show original. We're going to make... That should be green, I think. Let's try it. Find out. Yeah, Flyboy. I want to know... Well, if you come back to the next room, I'd love to hear what you ate. That sounds like fun. Line 40. Oh, look at that. Okay. Let's see what this looks like. Oh, original's not defined. We're so close. I actually want to show original. And oh, it's resized. 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 This should do it. Yeah. Okay. So now we have a robot that can roll around and at least see. So these, what would happen is these, the points, the x1, y1, x2, y2, the points and the lines it creates, you would actually use in either dead reckoning or your navigation techniques. So which we haven't got to yet, but now we have the ability to get to that. So we're going to use sensors on the Roomba. We're going to use the bumpers. We're going to use ultrasonic, and we're going to use maybe some IR because IR is built into it. And we're going to use these lines too. Now I don't know how I'm going to use them yet, but I know having them is going to help. So I've got these nice horizontal ones. So definitely if we see a nice horizontal, because we get the slope of these lines. So if the slope is 0, or maybe it's a threshold between 0 and something, it ran out of lines. Then we know maybe we're coming to an edge of some, we're about to hit a wall. If lines is not none, let's do that. So we can use things like slope. So maybe we know the slope of a baseboard is going to be whatever that slope is. We know this slope is definitely going to be some kind of vertical wall or vertical door. So maybe we can even do like a door finder where it looks for this gap or looks for two lines within a certain threshold that have a slope that's very close to vertical. There's all sorts of things you can do with it. One thing I would do, and I'll play with this, I'm going to make a polygon mask and try to mask out the floor. I think that'd be helpful. All right. Let's see. I enjoyed the Coneheads movie last night. That is old. That's Dan Aykroyd and who was the co-star? Fried waffles with strawberries. That sounds really good. Yeah, I could do that right now. Soundmaster says the relationship between the center of the video in pixels and the proximity, yeah, it's perfect, to the lines of particular angles. So we would have like CV2 get the image size, which is really easy to do. It's just called the shape in NumPy. So get the shape, get the center, at least maybe a threshold of center pixels, and then relationships between the center of the video, yep, and the proximity. And Paul says remove vertical lines. You can definitely do that too. So for each of these lines, you could do like the pseudocode would be like this: get slope, and then we can have vert lines as an array, and we could also have other arrays. But then we could say something like if slope greater than 5 and slope less than whatever it is. I don't know. -5. Rise over run. It's too early for math. Then we could add to array. Then add to vert lines. And then don't draw. Or we could say this. If it's this, then we know it's a vert line. Then we would say basically don't draw the line. So then we're not drawing the verts. Jane Curtin. She was a Saturday Night Live person too. So, Horse Ranker, pardon me for not knowing how you do this. I got a link here, an email rejecting a skill. May I ask a question about a problem? Sure. Paul says sure too. I created a custom skill following the daily horoscope model. For each day, there are 10 or more intents and utterances and responses. I need to change the responses on a daily basis, which take 24 hours, right? So, Paul, I'll let you answer it. My guess is, those should be dynamic. So you probably have these responses stored in a data or in your code, which would mean you'd have to be recertifying. But if you're pulling those from a database, then you wouldn't have to. But I'll let Paul confirm that and explain it better than I did. Basically, you're pulling dynamic data instead of hard coding the data in your skill. And it's no problem that you ask. If you have any questions, you can ask on this stream too. We usually have some good ask experts behind the scenes. Let's see if I missed anything. Yeah, I like there's some good ideas here, especially for masking, clustering. But look how many edges this found. You can really play around all day with the thresholds. What I thought would be cool, and I thought I might try on the stream, but we didn't have time, is to even make a brute forcer that shows, let's say, like 30 images of just this edge, but the edge with different variables. So it's just like looping through different thresholds. Maybe you could pick out the best one, but that might not be the best way. And I think it'd be pretty resource intensive, but it might be fun to try that. All right, we have another minute left or so. Horse, I think that will work for you. If not, just let me know. You can send me an email too. Let me paste my email here. And we can talk about it more there if that doesn't work. All right, I think I got your questions 2 ways. You can update slot values only, and if you change those values, it gets on the fast track. Hours, not days. Good. Soundmaster says you might want to keep some of the vertical lines because the difference between the shortest and longest lines might indicate the distance to the furthest wall in the room or something. Oh yeah, that's true. That's good. So yeah, you can see, well, these close ones are definitely, longer. They take up almost, I guess we're getting some reflection here, but they take up, I have grids on my floor, which is tricky too. But yeah, we know since this is a shorter line, maybe, it's probably not the best view. Let's start it over and look. But yeah, there's all sorts of theories on how we could do it. I think we should really start by creating a region of interest and masking out the reflection things, and then playing with the thresholds to make sure we're getting the right thresholds of gray. It would be fun too just to try this all, keeping it in RGB instead of grayscale. And I'm also resizing on the fly. I think it's moving a little slow. If we resized before and just worked with a 400 by 300 video to start, we'd see better performance too. Next stream on this, we're definitely doing a stream Friday. I don't know if it'll be on this, but want to start navigation, so maybe it should be. Maybe we should start telling the robot to move to the nearest door. So maybe we try that. I'll see what I can get done this week in the meantime. I think that might be a fun one. But yeah, if you've got ideas, Soundmaster, you have my email, so email me an idea, and I'm happy to look at it. Paul says dynamic entries pulls from a database, and there's no recert. So there's a good link for you, Horse. So hopefully that works. All right, everyone, thanks for joining. I had fun. Thanks for all your input. You had some great ideas, and it helped us get through this. So that was good teamwork today. So I appreciate it. Hope you have a good weekend. Flyboy, Flyboy, I know who you are. I think Flyboy might be my dad. Let's see. Flyboy 6 fishing. It is. That's awesome. Hey, Dad. Fried waffles with strawberries. That's awesome. I didn't get it till just now. So that's cool. Thanks for joining, and thanks everyone for your time, and I'll see you next time.